Hello, we're going to be looking at solving absolute value equations and inequalities. We have to remember that when we have an absolute value, we can change that absolute value into two statements without the absolute value. One would be that the absolute value, if x is positive, would be a positive x. Otherwise, if the absolute value is negative, we would get the opposite of x. When we deal with these inequalities and equations, we're going to want to rewrite each of these cases without the absolute values. Let's take a look at a couple of examples here. In the first example, we want to solve the absolute value equation for x. We have the absolute value of 7x minus 9 is equal to the absolute value of 6x plus 10. We will go ahead and write this without absolute values. I will have plus or minus 7x minus 9 is equal to plus or minus quantity 6x plus 10. We really have four cases here. We have plus, 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 minus, minus, plus, minus, minus. However, you might be able to see that two of these will be the same. The plus plus and the minus minus will be the same. The plus minus and the minus plus will be the same. I'm going to separate these into two equations without the absolute values. The first one will be plus plus. So I'll consider 7x minus 9 is equal to 6x plus 10. The next one, I'll do a plus minus in any order. 7x minus 9 is equal to negative the quantity 6x plus 10. If I solve for x on my left-hand side, I subtract that 6x over. X minus 9 is equal to 10. And then I will add over 9. X is equal to 19. On the other equation, I'll have 7x minus 9 is equal to negative 6x minus 10 if I distribute the minus. If I add that 6x over now, I'll have 13x minus 9 is equal to negative 10. And finally, if I add the 9 over, I'll have 13x is equal to 9 minus 10, a negative 1. Divide by 13 gives me x is equal to negative 1 over 13. These would be my two possible answers. I say possible because there's a possibility that these don't check out. What we would like to do is check them in the calculator. Let's try. If you go to Math in the calculator and scroll over to NUM, you have the absolute value. So I can plug in 19 for x and get the first side, 7 times 19 minus 9 is equal to 124. I can do math absolute value again and use the right-hand side. 6 times 19 plus 10. And that will also equal 124. So x equals 19 checks out. You can also verify by the same process that x equals negative 1 over 13 will check out. Those are my two answers. Now let's take a look at an inequality. With absolute value inequalities, we can think of this as a distance between x and 0 on the real number line. So we can actually think about this as a distance. When we're thinking about this, this says the distance between x and 0 on the number line is less than a. I can rewrite this statement into either a compound inequality or simply negative x is negative a is less than x is less than positive a. When I have absolute value of x is greater than a, that's the distance between x and 0 in the number line is going to be greater than a. So we're talking about the ends here. So I can write this as either x is greater than a or x is less than negative a. So they will be the ends of our interval. Let's go through an example and I'll sort of describe the process here. We'll look at it through the number line first and then we'll solve this algebraically. The first thing we'd want to do is isolate those absolute values. We would go ahead and divide by 2. And then I'm going to rewrite this just a little bit to show you the definition. This is the first step we would do either way we solve it. I would have the absolute value of y, I'm going to write minus a negative 3, is less than 9, 18 divided by 2. What this is saying on a number line is that the distance between some number y and negative 3 is 9. So intuitively, I can write it like this. My negative 3 is going to be my middle point. If I go to the left, 9, I have my left endpoint. That's going to be negative 12. If I go to the right 9, that's going to be my right endpoint. So adding 9, I would get a 6. Notice when I say the distance between y and some number y and negative 3 is less than 9, that distance has to be inside here, and that's why we would get this double inequality here. So my region would be right in here. If, however, this would have been greater than 18, then I would have this interval or this interval here. Since the distance is greater than, it would be greater than this interval here, and we would have the end regions here. Algebraically, this is what I want to do first. I want to set these up as one of these two systems without the absolute value. So I'm going to work with that down here. Y plus 3 in absolute values is less than 9. What that means is y plus 3 has to be between negative 9 and positive 9. When I solve for y, I just subtract 3 off of both sides. Negative 9 minus 3 is negative 12. Y plus 3 minus 3 is y, and 9 minus 3 is 6. There is my inequality. We like to write things in interval notation. In this case, we would have parentheses negative 12, comma 6. And that would be our answer that describes all the y values that work to make this less than 18. I hope this has helped. Thank you.